Hello, Classroom 9. Happy Monday. This is Miss S with another science lesson. So we're just going to get into it today. We're still talking about space. And then as the week kind of progresses, we're going to move on to learning a little bit about Mars. And then you guys will have spring break for a couple of days. And you won't have any classes. So let's just go ahead and get started. We're going to start with the video like normal, and then read an article and fill out the Google form. So let's just get right to it. I'm going to put it on just cam for now, or just screen for now while we do the video, so you guys can see the whole thing. Alrighty, here we go.
Hi, my name is Mannat Kaur. I'm here with Scholastic Kids Press. Today we're at SpaceX. It's out of this world. As a kid reporter, I get to investigate many subjects, like SpaceX, a company in California that designs, builds, and launches rockets and spacecraft. Rockets are massive, complex machines. They've been used for space exploration since the 1950s. They're the only vehicles powerful enough to escape Earth's gravitational pull. But so far, no one's built a rocket that can take humans to other planets. SpaceX is one company that is trying to change this. Its goal? To get humans to Mars and back. Recently, I got to visit the SpaceX factory. I met Gwen Shotwell, the company's president and an engineer.
Hi, I'm Gwen Shotwell. I'm President and Chief Operating Officer of SpaceX. So at SpaceX, we're building both rockets and spaceships. The rockets that we're flying right now are the Falcon 9 rocket and the Falcon Heavy rocket. And within a couple of years, we'll be flying the Big Falcon rocket, BFR. We're also building spaceships. The Dragon spaceship we're flying right now to and from the International Space Station. And in just a few years, we'll be flying the Big Falcon spaceship, which is part of the BFR rocket system. And BFR and the Big Falcon spaceship will be the initial ships that take people to Mars.
To successfully launch a rocket, you need to accelerate fast enough to escape Earth's gravity. This is known as escape velocity. It is achieved by burning liquid rocket fuel and oxygen to create thrust, a force that pushes an object.
The thrust has to be heavier than the weight because you have to fight gravity. So a rocket whose thrust is less than its weight can't get off the pad.
The Falcon Heavy rocket is the biggest rocket currently flying. It weighs more than 3 million pounds and can lift more than 70 tons into orbit. Like other SpaceX rockets, one of the Falcon Heavy's most important features is that it's reusable. This is critical for creating a rocket that can make a round trip to Mars.
So in order to get to Mars and back, you have to have these rockets and spaceships be reusable. Right now, outside of SpaceX, after the rocket is used, it gets thrown away. And so if you took people to Mars, that might be super great, but you couldn't bring them back. In order to have a round trip ticket, you got to make sure you can get there, reuse the system, and come back. When you bring the rocket back after the mission, you get to examine it and inspect it and see how it did. And if you have weak points in the vehicle or in the rocket, then you can redesign that particular part.
Another big feature on SpaceX rockets is that they use a technique called propulsive landing. In this method, they use the engines to slow the rocket down for landing. The rocket ships have landing legs, which fold out and lock in place on descent. These help rockets land precisely on the ground or on a drone ship in the Pacific Ocean.
So it has to land very precisely because the ship is actually not very big, not compared to the rocket.
Not all rocket launches go as planned. Sometimes they fail. Yet these experiences are the most helpful to engineers.
People learn far more from their failures than they do from successes. You tend to have a success walk away, think about the next thing, and not think about all the things that could have gone wrong. When you have a failure, you know exactly what went wrong, and you go in and you fix that part of the system. Engineers are never satisfied. They always want to play with the design or tweak the design or test the design or reanalyze the design. STEM fields are changing the world. They have in the past and they will in the future. So be part of that.
Meeting a STEM superstar like Gwen Shotwell was something I'll never forget. Thanks for joining me on my tour of SpaceX. Maybe next time, I'll see you on Mars.
Alrighty, so I just thought that was interesting, just to learn a little bit more about the different rockets and how it works, because it's just amazing to me that they're able to send these, this one here that they were talking about, they said it was like 300 million tons, I think. Like that's a lot of weight to be able to 3 million pounds. So that's a lot of weight to be sending straight up. So I just thought that was very cool. Hopefully you guys did too. Today we are just going to read this article called Rocket Woman, and then you guys have 1, 2, 3 questions, and they're actually all the same questions, so you just have to give me 3 different answers. So I think it shouldn't be too difficult, but let's see how it goes. We're going to zoom in on this side and start over here. So this is called Rocket Woman. At SpaceX, Gwen Shotwell works to advance space exploration. Today, typical rocket launches are expensive, not to mention wasteful. A single launch can cost more than $70 million, and most rockets are discarded after just one use. Because if you remember, a lot of them don't make it back in one piece, or they make it back damaged. So it's $70 million for something to only be used one time. But SpaceX is working to change this. The California-based company, founded in 2002 by entrepreneur Elon Musk, has become a leader in the growing private space industry. For decades, government agencies like NASA were the main players in space flight, but SpaceX now regularly launches satellites into orbit and sends supplies and science equipment to the International Space Station. SpaceX has also advanced rocket design by making rockets that are reusable, which saves money and could allow astronauts to make return trips from other planets. One of SpaceX's first employees, Gwen Shotwell, helped the company take flight. The engineer is now SpaceX president and chief operating officer. She oversees more than 6,000 people, most of whom focus on designing, building, and launching rockets and spacecraft. Science World spoke with Shotwell about her job and SpaceX's ultimate goal of building a colony on Mars. So like I said at the beginning, we're kind of moving on from space to now Mars for this week. And I think it's going to be interesting to see what they want to do to Mars, like how they want to build and make this, like, make Mars kind of habitable, per se. So if you look at the picture, the caption says, "The big launch, the most powerful rocket currently flying is the Falcon Heavy. It's generated 5 million pounds of thrust when it launched in February of 2018. So that was a little over 2 years ago. And again, the thrust is when it's leaving the ground and going up. And then, as we saw in the video, That is the SpaceX president, Gwen Shotwell. So, first little section right here. I keep pointing, like my laptop is, side note, my laptop is touchscreen, so like when I'm moving and you don't see the mouse, it's because I'm moving it touchscreen. And then I try to point to it using the touchscreen, and you guys can obviously not see that, so just bear with me. So this paragraph is where we're going to start. What does it take to get a rocket off the ground? Rockets are massive, complex machines. We launched the Falcon Heavy rocket in February 2018, and it's the most powerful rocket currently flying. It weighs about 1.4 million kilograms, which is equivalent to about 3.1 million pounds, and can lift up to 63 tons into orbit. Rockets like the Falcon Heavy burn liquid fuel in the presence of oxygen to create thrust. This force pushes the rocket upward. The rocket's thrust has to be greater than its weight, otherwise the rocket won't make it off the launch pad. The thrust created by the Falcon Heavy at liftoff was equal to the force produced by 18 747 passenger jets. So, that's just amazing. I don't even know what to say. Another little side note, when I took my first flight ever last January in 2019, I just could not believe that I was in the sky. So, like, I can't imagine being in one of these rockets and actually, like, going out of Earth and being in outer space. Like, I just can't imagine all the technology and science and everything that goes into making this successful. Next section, it starts down here, and then we move up by her picture, okay? So, how do SpaceX's reusable rockets work? Right now, we carry out all of our missions with our Falcon 9 rocket. It's a tall, cylindrical tube that houses engines and fuel in two separate stages, or sections. The first stage lifts the rocket from the launch pad and sets it on a curved trajectory, which means path, through the air. It then separates from the second stage, which continues carrying the payload into orbit. So, when it means cylinder, it just means kind of like this round shape, like a water bottle. That's all a cylinder is. So, again, the first stage lifts the rocket from the launch pad and sets its path. And then at the second stage, they separate. So, in the video, you saw these two sides separated from the middle part. Next paragraph, we can recover the first stage rocket to reuse with a technique called propulsive landing. As the first stage falls away, thrusters flip it around so the engines are pointing downwards. The engines fire multiple times to guide the rocket toward the landing pad on the ground or a drone ship. It's incredibly difficult to steer the rocket so precisely. Once it gets close to Earth, the engines fire again to slow down its descent for a gentle touchdown. As the rockets land, legs fold out to hold it in place. Alrighty. So, the next part is what is SpaceX doing to prepare for human exploration of Mars? Reusable rockets are the first step. Without them, astronauts who someday visit Mars will have no way to get back home. We've been working for a few years on designs for a spaceship that will take people to Mars. It will be able to carry 100 tons of cargo and 100 passengers. A round trip to Mars will take about 2.5 years. so astronauts will need to take a lot of supplies with them to survive the long flight. We're starting to build the spaceships now and are hoping to do some testing of it this year. We're aiming to send people to Mars within the next 10 years. Getting there will definitely happen in our lifetime. And then last but not least, this last paragraph. When it comes to engineering rockets, do things always go as planned? And remember, this is kind of set up as like an interview. So the girl that was in the video, she asked these questions to our SpaceX president. So her answer is no. We've had rockets explode, crash, and fail to land, but people learn far more from their failures than their successes. With success, you tend not to think about what could have gone wrong. With failure, you can figure out what went wrong and fix it. I'm going to read that again because I really like that, not only for science, but just as a general thought of life. So I'm going to go back, read that one more time. Maybe I'll highlight it too. Let's do pink. Highlight it first. I really like that saying. Alright, here we go. With success, you tend not to think about what could have gone wrong. With failure, you can figure out what went wrong and fix it. Engineers are never satisfied. They always want to tweak, test, and reanalyze a design. So again, everything is always learning, and especially in this day and age where technology is advancing faster than anyone could ever have imagined, things are changing, things are getting better, things are like computers are making jobs easier, maybe making them harder. So it's always trying to figure out what is going to be the most efficient and best way to achieve the goals. So, and then at the bottom, this is the part of the SpaceX rocket in the factory, at the factory in California. So, there's our little article. So, for your questions, you are identifying 3 challenges engineers might encounter when building spaceships that can transport humans and supplies to Mars and back. And then I kind of put like a little helper hint. These issues might be related to the function of the spacecraft, safety of the crew, or challenges linked to conditions of space, Earth, and Mars. So, really, there are some wrong answers, but mostly what you're going to tell me is, like, whatever you are thinking is probably right. Again, I have 3 different spots here. They're labeled 1, 2, 3, but they are the exact same questions. I just want 3 different examples. There were some in the article too. So thinking about even just that last section that we read, the second sentence, rockets explode, crash, fail to land. There's one right there. Sometimes the technology just doesn't work. What are some challenges that they face the difference between Earth and Mars? They don't have the same gravity. They aren't the same, planets. That could be a challenge. How about having enough supplies for people to get to Mars in the 2.5 years that it takes to get there? So there are tons of different things within the article, but I'm sure just having that common knowledge that you guys all have, you will probably be able to come up with ones that might not even be in the article that are legitimate challenges. And I don't think this is too hard. I think you guys are all going to be fine with it. Just try your best. That's all I'm asking for you. Other than that, I don't think I have anything else. So I will see you guys on Wednesday for the next science video about Mars. Have a great day, everyone.